Okay, so we're going to work on the second half of Chapter 7 now, and we're going to begin by talking about how you study relationship in tables that are larger than 2 by 2. Now, the first number, when I say 2 by 2, this is conveying the number of rows. The second number, the number of columns. So, for instance, a 3 by 4 table has 3 rows and 4 columns. So as we look at a relationship in larger contingency tables, I'm going to go back to our difference in percentages measure. I mean, this is an informal measure. This is almost how, by instinct, researchers examine relationship. They look at differences between percentages. So 2 by 2 tables have several different ways that you could look at the difference in percentages. I mean, for instance, you could compare the percentages in the top row or in the bottom row, or you could subtract one percentage from the other or the other from the first. But in essence, a 2 by 2 table is going to generate for you only a single difference in percentages. Whereas on the other hand, when we have a larger table, each variable has more categories, and so there are more comparisons that we can make. So in essence, the larger tables are going to generate multiple difference in percentages, multiple comparisons of percentages. So, I mean, just in an informal sense, what we're going to do here is take a table larger than 2 by 2 and look at some of the differences in percentages that we can find in that table. And basically, in our informal way of going forward here, if we're finding on balance larger differences, that's conveying stronger association. If the differences tend to be smaller, then we've got a weaker association. And I mean, I'm going to go ahead and calculate an average difference in percentages in the next slide or so. You know, again, this is just an informal measure, but it gets at how researchers assess size of association. So here is a 2 by 3 table. Our row variable is, does the child have serious behavior problems? Yes or no. And our column variable examines family ethnicity. So in the special needs adoption research that my colleague Victor Groza and I did, we divided families into 3 types, and most of the families fit one of these 3 types. So minority inracial families, at least one parent is a minority, and the child is the same race as at least one minority parent. White inracial conveys a white family, white parents adopting a white child, and the transracial families were predominantly white parents adopting children of minority ethnicity. So family ethnicity is our column variable. I'm going to go ahead and demonstrate 3 comparisons, and then the next slide will show our calculation of difference in percentages. We're going to use the top row to make comparisons. I mean, you could use the bottom row, but one comparison would be minority inracial versus white inracial. A second comparison would be minority inracial versus transracial. A third comparison would be white inracial versus transracial. So each of these comparisons is in essence going to generate a difference in percentages, and we can informally look at the average difference in percentages to get a rough approximation of size of association. So here are the calculations of the difference in percentage for our 3 comparisons. So for the minority inracial versus white, we take 46.6 and subtract 29.4, and that's 17%, and I'll go ahead and round here. Minority versus transracial comparison is 37% minus 29, about 8%, and finally the white versus transracial difference in percentage calculates to about 10 percentage points. So, referencing back, and I'll just speak again informally, this difference of 17 percentage points, our table of qualitative descriptors said about 18% is medium-sized association. So there's a medium-sized difference in percentages for this comparison. And then our qualitative descriptors table suggested that about 7% conveyed a small or weak size of association. And so these two comparisons here are both close to that small size of association. So if we sort of sum things together, we've got one medium-sized difference and two small ones, so that therefore overall the size of association, we might say, is somewhere in the area of small to medium. And if all of the differences are in the same direction, I mean, we could indeed sum these up in this case and divide by 3 and then sort of get a rough average difference in percentages. But we won't carry out that calculation. It's enough to say that we've got a medium-sized difference and a couple of small ones, and so we have sort of overall size of association that's in the range from small to medium. So discussion in that last slide was to convey informally how researchers peruse contingency tables to make a beginning judgment of size of association. But I mean, it would be great to have a measure of size of association that worked well for tables larger than 2 by 2. So I mean, recall that the difference in percentages, the risk ratio and the odds ratio all work for 2 by 2 tables. So an excellent measure for tables that are larger than 2 by 2 is Cramer's V. I do indeed think it's the best measure, or I mean, it's a very good measure of size of association for nominal level variables in contingency tables that are larger than 2 by 2. We're going to talk soon about relationship between two ordinal variables, and sometimes Cramer's V is not the best measure in that situation. Cramer's V can vary anywhere from 0, which is conveying in essence absence of association, to 1, which is conveying the strongest possible association between two nominal level variables. And I'll just note that this slide should say RR for risk ratio, not R percentage. Here are the qualitative descriptors for size and strength of association for the correlation coefficient R that is in Chapter 8. I'm going to suggest that these descriptors work reasonably well in helping you assess size of association conveyed by a given Cramer's V. For Cramer's V, a difference is Cramer's V does not take on these negative values, so your focus would be on the positive ones. I'm not going to discuss calculation of Cramer's V, but I calculated Cramer's V for the family ethnicity behavior problems example. It computed to 0.16. So you could consult table 8.2 and see that that's intermediate between small and medium. So again, we have basically an association that is fairly small in size. So I'm going to go ahead and introduce the notion of directional relationship. And in Chapter 7, we're going to be working on directional relationship between two categorical variables. And I'm just going to mention that Cramer's V is often not the best measure for strength of directional relationship. I guess I should go further and say that when we have directional relationship, Cramer's V isn't a good measure to use, and I'm going to present some other ones. So, notion of directional relationship, calling in the idea of increase and decrease in values. So, if we have a positive directional relationship. That's conveying that both variables change in the same direction. As one goes up in value, so also does the other. And by the same token, as one goes down, the other changes in that same direction. In a negative directional relationship, variables change in opposite direction. As the values of one variable go up, those of the other go down. Or we can say that differently and say as one goes down, the other goes up. For a relationship to be a directional relationship, it must be the case that both variables in that relationship are at the ordinal level or higher. So consider the variable eye color, blue, brown, green, etc. Eye color cannot have a directional relationship with any other variable. That's because values of eye color can't go up and they can't go down. They can't be ordered. They can change from blue to brown to green, for instance, but there's no ordering to the values. So therefore, if one of two variables, or for that matter, both of two variables, are at the nominal level of measurement, then it's impossible for those variables to have a directional relationship. Now, I think you have a good intuitive sense of directional relationship. So for instance, here are some variables that I suspect have a predominantly directional relationship. A person's height and the length of their foot. And again, this is going to be positive relationship because taller people tend to have longer feet. As height goes up, so also does length of foot. Here's another relationship that, for the most part, I think is going to be positive. How long do you study for an exam, and what score do you earn on that exam? As our study goes up, so also do scores. Now, we'll discuss this in Chapter 8. I think it's possible to study, for instance, too much for an exam and get so tired and frayed that your score starts to go down from overstudy. But for the most part, we're going to have a directional and positive relationship. And again, this third one is positive directional relationship. As education level goes up, so does income. And I'll just sneak in a comment. We're not saying that everybody with high education level has high income, and everyone with low education level has low income. But the idea is the trend, the pattern is there. That's the nature of relationship, and the nature of directional relationship is that there's a direction to that relationship. As one goes up, the other goes up, or as one goes up, the other goes down. Positive and negative directional relationship, respectively. So let's take a look at a directional association example. We've got two variables. Our column variable is age of graduate student. Our row variable is level of motivation. And you can see that both of these variables are ordinal level. So as you go from left to right here across the columns, age is going up. That's directional change. And as we go from the top row towards the bottom one, motivation level is going up. So we've got two ordinal level variables. That means potentially, not necessarily, but potentially there's directional relationship between these two variables. I do the best I can at just describing the directional relationship here. And what I'd suggest we do is look at age group going up, which is from left to right, and then we'll focus on the unmotivated and the motivated row. So as age group goes up, what happens to the percentage of unmotivated students? And you can see the percentage goes down from 25 to 20 to 10. It decreases. Now let's look at what happens as to the percentage of highly motivated students as age goes up. And the percentage of highly motivated students goes up from 30 to 40 to 50. So take a little time to study this table to see that the basic pattern in this table is that age group and motivation are changing in the same direction. As age group goes up, so also does motivation level. So as age group goes up, we get more and more highly motivated students and fewer unmotivated students. So we've got here an example of positive directional relationship between two ordinal-level categorical variables. So now we've got the same two variables on this new slide. I mean, we've got relationship in our new table here because percentages differ. So the percentages in this column are not the same as those in this column and are not the same as those in this column. So the percentages differ. Therefore, we've got relationship. Now, both variables are ordinal level, so the potential is there for a directional relationship. So what we need to see now is, I guess in particular, let's hunt for, have we got positive directional relationship? We want to look at whether as age group goes up, so also do the percentages of highly motivated students. Let's examine the unmotivated row. So as age group goes up from 25 to the middle age group, the percentage of unmotivated students is increasing. But on the other hand, as we go from the middle age group to the oldest age group, the percentage decreases. So, I mean, we've got a change in percentages here, but it's not in the same direction. It's not constantly going up. Our change in percentages, I mean, first our percentages went up and then they went down. Now then, let's go focus on the highly motivated students and see how those percentages change as age group increases. So for the 25 and younger group, we've got lots of highly motivated students, 50%, and that percentage goes down as we go to the middle age group, but then it goes back up again. So we've got differences in percentages again here. This again is conveying relationship, but we've not got a consistent pattern of change in the same direction. So for instance, here our percentages don't go 50, 30, 10, or here they don't go 5, 25, 50. To summarize, we don't have consistent change in the percentages in one direction, and so therefore we don't have a directional relationship. So this is an example of non-directional relationship between two ordinal level categorical variables. I like to think of Cramer's V as getting at the overall size of association in the contingency table. So I like to think of Cramer's V at getting at the size of association in the table without taking any account of direction of relationship. So Cramer's V sort of focused on all of these comparisons between percentages. Are the comparisons between percentages in essence yielding most often very small differences in percentages, or are many of these comparisons yielding very large differences? So that's what's generating the value of Cramer's V, and Cramer's V is generated without in any way taking into account whether there's a directional pattern to the relationship. Now when you've got directional relationship, Cramer's V is not per se wrong, but it's not optimal. It's in essence capturing the overall size of relationship without regard to direction. This slide lists some good measures of directional association between ordinal-level categorical variables. One problem perhaps is there's not a single best measure, but tau b has a good measure of directional relationship in square tables, that is, for instance, the same number of rows and columns. A 3 by 3 table is square. On the other hand, tau c is better for non-square tables. Summers d is a good measure of directional relationship in situations where one variable is clearly independent and the other is dependent. The other is clearly dependent. And a final measure of directional association between two variables is gamma. I will note that gamma often calculates to a value that is an absolute value that is higher than that of the other three measures. And sometimes the value that gamma calculates to can be artificially high. I will note that these measures can take on either positive or negative values. Think of them in essence as varying from lowest possible value of -1 to highest possible value of 1. The closer to 0, the weaker the relationship. But I will just note that some of these measures in some situations can't take on possibly values of -1 or 1. So the notion that they vary from -1 to 1 is sort of an approximate notion to help you get a feel for these. And I believe, I'm not sure, that the absolute value of gamma can even calculate to be greater than 1. You can use that same table that we looked at for Cramer's V to just get a rough gauge of size of association conveyed by one of these directional measures. And a difference is that, with Cramer's V, the value is always positive. It varies from 0 to 1, whereas these measures vary from -1 to 1. So take that into account as you look at the table of qualitative descriptors. I've gone back to the qualitative descriptors guide, and the value of tau c in our example calculated to 0.19, and so that would be interpreted as a relationship that is small to medium in size. And I guess I want to further say, it's a positive relationship.